So these are the notes for 5.3, and 5.3 is titled Money That Makes Money. So this is kind of the secret to financial freedom here, and that is that we want to get our money to make money for us without us doing anything, and this is the way that this happens. So the storyline that goes along with these notes is that Michelle mows lawns during the summers to earn money. At the end of the summer, he wants to put $500 into a savings account for the next 3 years. The savings account at his local bank earned 4% interest each year, which is added to the balance of the account. So how much is he going to have in 3 years? So the idea here is that he's going to put money away, and he's going to let it earn interest, which means he's setting it aside so that it can earn money for him without him having to do anything. So the interest earned then is 4%. So, and that's each year. So that is what we call an annual interest rate, 4%. And we know that 4% as a decimal is 0.04. That's how it has to show up in calculations. And so in the first year, he takes $500, and it earns 4% interest. So times 0.04, and that is $20, and that is the interest earned. So at the end of year 1, he's got $520, and he's going to keep that $520 there. So at the beginning of year 2, which is basically the end of year 1, he's got $520 in the account, and that $520 is going to earn 4% interest. So you see what's happening here is this interest, let's just pause this here, this 4% interest, this entire $520 is earning this 4% interest. Not just the original $500, but the $20 we earned in interest in the first year is also going to earn some interest in the second year. And so now the interest earned is not just $20, but it's $20.80. And so now, adding that to 520, we have $540.80 at the end of year 2. And so that is the balance then at the beginning of year 3, $540.80. And that $540.80 at the beginning of year 3, as we keep this in here for 3 full years, is going to earn 4% interest. And so the interest that we earn in year 3 is going to be $21.63. And I should put a multiply sign there, times, there we go. And so adding that $21 then to the total is going to be $561. $561 and $562.43. So if you notice, then over the course of 3 years, we have $62.43 more. So let's take a look at the math behind this, because making this table line by line, while it's not bad for 3 years, typically we invest for decades. So, 10, 20, 30 years. We don't want to make a table that's 30 lines long just to figure out how much we're going to have in 30 years. So we need to develop a mathematical model so that we can find out how much we have, say 10 years out, like this question is asking down here. So when we look at this and generalize it, to get, what we basically want to do is we want to jump over this middle column. So we want to go right from here to here. So if we did that, think about what we did here. We took 500 and times 0.04, we got 20, and then we added the 20 to the 500. So really, if I put a plus sign here, 500 plus 20 equals 520. So this really is 500 times 1.04. Check that out on your calculator. That's going to give you 520 directly. The 1 stands for the full 500, and the 04 stands for the interest earned in that first year. And then looking at this, same holds true. We got 520 plus the interest equals that. But the 520 was already the 500 times 1.04. So this ends up being then, if we kind of pick this apart, this 520 is really 500 times 1.04, and then this is more interest on that. So this ends up being 500 times 1.04 squared. In other words, we've had that interest for 2 years. And so this last one then ends up being 500 times 1.04 cubed. So what we see is an exponential relationship. With that power changing for every year, we keep that money in the bank account. So after 10 years, our balance here is going to be 500 times 1.04 to the 10th power. And so that is going to be equal to $740.12. So we're going to earn $240.12 of interest on that money over 10 years. And so in general, the balance, we'll call that B for balance, the balance on the account in general is going to be, for this problem, because we started with 500 and because we have an interest rate of 4%, it's going to be, for any time t, it's going to be 500 times 1.04 to the t power. And so when things are compounded annually, each year, that means annually, that is the relationship they follow. Now, what happens is sometimes we don't compound things annually. Sometimes we compound them more frequently than that. And the nice thing is every time we have to do this interest calculation, that means we're calculating our money, we're earning interest on our money, and that interest is earning interest for us as well. So the more frequently we can compound the interest, the more money we can earn. So let's make a table for something that is compounded twice a year. So every 6 months, which means we're going to need more columns. We're going to have a interest earned in the first 6 months and a balance after that, and then interest on the second 6 months and a balance on that. Let's do that for 3 years. So the same duration, but more frequent compounding of the interest. We're still going to stick with 4%. So the interest in the first half of the year is going to be 500 times 1.04. So that's going to be our 500, not 1.04, excuse me, 1.02. So why is that 1.02? Well, I'm trying to find it in the statement here, and I can't, it doesn't explicitly say in the statement, but this kind of gets to it right here. Half the interest is added halfway through the year. So if we have a 4% annual, we call that APR, then we are going to do 2% every 6 months. So that's why it's 1.02. And so that is $10 of interest in the first 6 months. Now you might think, well, geez, then over the year it's 20 bucks, but it's not exactly. After 6 months we have $510, but now in the second half of that year we're going to take that $510 and let that earn 2% interest. And it's going to bring in, it's not going to bring in another 10 bucks, it's going to bring in another $10.20. So now we have, after the end of the first year, we have $520.20. So in other words, we've got 20 more cents. Okay, so we're going to let that at the beginning. You might think, well, 20 cents isn't a big deal, but think about doing this over decades. That's going to really add up. So now we're going to start with $520.20, and for 6 months, we're going to let it earn 2% interest. And that is going to be $10.40. And so we're going to have $530.60. And then we're going to let that earn 2% interest, so $530.60 times 1.02, and that's going to bring in $10.61. So now we're going to have 500, I'm trying to add this on the fly, that would be 41.21. So we can see we're already beating our previous by about 41 cents. And then for year 3, we start at 541.21, and that's going to earn 2% in the next 6 months. And that's going to be another, what is that going to be? That's going to be $10.82. $10.82 in interest. So now we're going to be up to $542.04. No, 3 cents. Yep, 3 cents. My bad. I didn't add that right. 3 cents. There we go. And then for the last 6 months, we're going to take that 542.03 at 2% interest, and we're going to earn $11.04 of interest. I just noticed a mistake, so let's pause here. This should be 0.02. 0.02. Because I'm just calculating the interest, and this should be 0.02. There we go. And so our total balance after 3 years is $563.07. So if we follow this back through, we multiplied by our 2% interest 1, 2, 3, 4, 5, 6 times. So this is equal to 500 times 1.02 to the 6th power. So if we notice, this is the 6th power is the fact that we are compounding twice a year, right? So we have half the interest rate, so we have half the rate here, but we have half the rate for twice the compounding, twice the power, twice the compounding times, right? Not 3, but 6. And so to figure out how much we'd have after 10 years, so comparing that back, it looks like we have another 64 cents over 3 years. Let's see what we have over 10 years. So if we would take this $500 and at 4% APR, that means we're compounding it at 2% twice a year. If we're at 10 years, then we're at 20 times, because it's twice a year, we're at 20 times of calculating the interest. So power of 20 up here. And that gets us to $742.97. So now we're starting to get $2, possibly $3 more over that time. And I know it doesn't sound like much, but again, if you're investing larger amounts of money at a higher interest rate, that difference becomes significant. So what we're doing then is we're saying let's take a look at compounding more frequently, which means we are looking at dividing up that interest rate a few times a year. So that balance then in general is, for this problem, if we start with $500 and we calculate that each time we make that interest calculation, it's going to be 2%, then we have 2 times t years. So 2 times 10 is 20 times that we've compounded. And so now we can kind of start to generalize. If we want to compound 4 times a year, then 4 times a year, our interest is 4% divided by 4, which is 1%. And now we're calculating interest 4 times a year. So our balance then in this situation would be 500 times 1.01 times to the 4t power, because we're going to be calculating that interest 4 times each year. And so we can even further generalize that by saying that if we want to just generally speaking, compound n times a year, then that interest becomes 4% divided by n. And the compounding, or the interest calculation, becomes n times t. So this balance then for this problem would be $500 times 1 for the initial $500 investment plus, and then we would have 4% divided by the number of times a year we're going to calculate this, all to the nt power. So number of times we're going to calculate times number of years we're going to keep it into the bank account. And so this gets this gets into the really general expression for exponential compounded interest. And that general expression is that the balance of any amount of money invested, which we call principal, so we call it big P, is then the interest rate as a decimal divided by the number of times a year we're going to calculate that balance to the n times t power, where P is the initial and we call it the initial principal. So initial principal is kind of a financial talk for like the amount of money you start with. It's that initial, like for these problems, it was the initial $500. So that's how we can calculate then, and like I said, at the beginning of the notes, get the interest to make money for you without you really having to do anything. And so our two learning targets then, the two areas of focus that we're going to have on this, is that the first learning target has to do with writing the exponential. Okay, so writing that exponential relationship. And so in general, if we have a function with an annual rate of change, so in general with an annual rate where we're compounding annually, not any more frequent than that, then we have, we're in general terms writing it as a function, so that would be the balance, equals, we're going to stick with this a, the starting value being a plus 1, a times a quantity 1 plus r to the x power, right? We're writing this as a function like if we would graph it. So a would be our initial value, so the $500 or our principal, and the r is the percent growth. I'm going to scooch that down a little bit. A is the initial value, our r is our percent growth. It could also be a decay, really. So it's a percent growth, that would be with the plus sign, or it could be a percent decay if we would put a minus sign, and of course this has to be written as a decimal. And then learning target 2 then is to kind of focus on the financial aspect and modify that for compounding more frequently than once a year. So this is the idea of compound interest. In other words, your money making money. And so then we start to use this financial sort of vocabulary. The balance is equal to the principal times 1 plus our rate as a decimal over the number times a year we're going to calculate our interest, and then that all raised to the power of the number of times we do that times the number of years we're going to leave it there. So that's our total number of times we've calculated. And then where P is the principal, the principal or the initial, that's our initial amount, initial investment. And the R is the interest rate as a decimal. And then the N is the number of times each year. Interest is calculated, and we call that compounded. And then T is the number of years we let this be invested. And so as you're working on the check your understanding, I have a few answers here to help guide you. Just to kind of help guide you to see if you're getting the right answers here as you're working on these compounding questions. And then for if you notice down in the homework, I've got answers for each one so you can check your progress as you go. And then just to kind of highlight it here, I split out the growth formula and the decay formula for that annual calculation with the plus and the minus. And then we would also have then our compounded interest. We could probably put that right there too. Compounded interest formula of balance equals P1 plus R over N to the N times T. And then, of course, answers